All right, I want to go ahead and take a look at the practice exam for tomorrow. So we have a missile launched at 60 degrees and it has an initial speed, sorry about that, of 100 meters per second. So let's go ahead and take a look here. Now, your first projectile motion problem is going to tell you right now, I just want to make sure that you can make effective use of the formula. So it's not going to be too complicated. When I ask you for the height, you should simply use the height formula. And when I ask you for the hang time, you should definitely do the same thing. And finally, when I ask you for the range, go ahead and use the range formula. So what I'm simply going to do is plug in the numbers and get my answer. So this will be 100 squared times the sine squared of 60 all over 2 times 10. The number here will be 2 times 100 times the sine of 60 divided by 10. And this last one is going to be 100 squared times the sine of 120 divided by 10. So when I actually work out all of these various numbers, for the height, I will end up getting about 433 meters. This will be about 866 meters. And as far as the time goes, this is going to be 20 times square root of 3 over 2, which is going to be 20 times 0.866. 20 times 8.6, sorry, 20 times 0.866. So we do that. That's going to end up being 8.66 times 2, which ends up being about 17.32 seconds of hang time. So that's question 1A. Now, things change in question 2. And this is one of those things where I see a lot of students taking a lot of different guesses here. Let's keep this really simple. This is a projectile motion problem. Don't try to invoke other formulas. We're talking about the range. So even if this problem doesn't seem to make sense, go ahead, write down the range formula if we're talking about range. Even if you don't think you have the angle or you're not sure what's going on, just go ahead and use it. And let's plug in what we have so far. So I know the initial speed is 100 and I can square that. I don't know the angle, and I know that g is 10. Now, is there any other information we can get from reading the problem? Well, we're told that the object was a distance r equal to 866 meters away, and it's been moved 1/4 of that in. So we're only 3/4 r away. So that means the new range is very much like the old range, but it's only 3/4 of it. So our new is going to be 3/4 times 866. When we round that decimal, we're going to end up getting 650 equals 100 squared times the sine of 2 unknown theta all over 10. When I simplify this, I'm going to end up getting 0.65 equals the sine of 2 theta. Now, what I'm going to do is simplify both sides. I'm going to write this in a different color because if you get to this point here, you're really at 9 out of 10 on the problem. Simplifying the trig, we're going to take the inverse sine of both sides. And so this ends up giving us about 40.54 degrees equals 2 theta. And so when we simplify, we're going to end up getting theta is 20.27 degrees. So that's it for part 1. We'll take a look at part 2 in the next video.